class. I'm posting solutions this week for the animal fights problem set. I thought it's always useful for me to just sort of go over what I did, some of the things we learned during class, and highlight a few pain points. So I thought I'd just do one of these think aloud exercises again and go through how we arrived at our solution set. With that, let's get started. So the first thing I did was, this is just a modified version of the problem assignment, and we'll rerun everything up until you got it. We got our clear all, so we cleared our workspace. We're using the file that we're supposed to. And our first question: how many variables are there in the data set, and how many observations? So the command we're using right now is called describe. And the neat thing about R that I want to show you and highlight that is really useful, particularly as you start to do more and more things programmatically, where you don't necessarily want things to depend on specific values of your data set. There are these commands called return list. And what that will do is when you run a command, it will store values and relevant fields that might be of note. So in this case, when we type return list, some of the things that you start to develop an understanding of is that K corresponds to the number of variables in our data set, N corresponds to the number of observations. Sometimes it's a little bit difficult to understand where these things are coming from because these things aren't necessarily the most documented. And in fact, I will have to get back to you on some of the best ways to sort of figure things out. But generally, if you look at the help function associated with a command, it will let you know its return type and what those variables correspond to, even if the name is not immediately intuitive to you. I always recommend you go here and look first. Additionally, there are some other commands that we'll talk about that are similar in terms of having these returnable features, but the way in which we generate them can be a little bit different. And what we're doing is we're trying to access these hidden variables, these sort of hidden variables with these things called macros. And in short, sometimes you don't want to retrieve a specific value. You want to retrieve the name of a variable. And so that way you can use things programmatically. So for instance, instead of displaying RK, I'm printing out how many variables and how many observations in my data set. And to access the underlying values, we have to use this sort of notation of a apostrophe and the forward quote and the back quote. I will send out a working document on macros and these abbreviations. I'm not sure how much we're going to be able to cover it in class, but I want you to know that there are ways to do things programmatically that are a little bit more flexible depending on your needs. So in terms of what this data set is, I think we went over it in class, but it was a YouGov survey about whether or not individuals could beat various animals in a fight. We also have the demographic data. And the next question, and this was one that I think got a couple of you, was this: what does the variable gross household R mean? So quite a few of you ran the codebook on it and saw that it was several survey questions on an individual's income. The one thing that is kind of tricky about about Stata is that you have these labels that don't necessarily correspond to the representation of the data necessarily. So you see here we have codes 1, 2, 3, 4, and their associated labels. So for instance, an individual making under 40K is coded as a 1 in our data set. And what I saw a couple of folks do is instead, when we asked to understand whether or not individuals who make more money, are they college educated, I saw folks taking the mean of these data, which in a case like this really doesn't make sense because we'll talk more about the scales of variables, but this 4 don't know category is completely different than what 3, 2, and 1 are. So in some sense, if we get an average of 3.5, it doesn't have real interpretability. So that's one of the things that I want to highlight. The other thing that I want to talk about is that these labels can be confusing unto themselves. So there are a couple of ways you can generate variables if you either want to drop them or keep them. By default, labels are removed whenever you generate based off of the same feature. So for instance, right here, we're going to generate a variable called unlabeled income. And all we're using that generate command. And we're going to do the same thing with clone variable. And what I want to show you is that clone variable, when you look up the description, you can see it's an exact copy of a prior variable with storage types, values, and display format, including labels, notes, all of those sorts of things. So we're going to run that command as well. And what we see when we compare a table of the two is we see that even though the number of elements across the diagonal are exactly the same, that the associated labels of each of these correspond to either their numeric value, 1, 2, 3, 4, or their label when you generate a tab. Cool. Now, the next thing I wanted to show you is that generally, at least with Stata, there's always a way to do the exact same thing with a slightly different phrasing or expression. In set theory, this is something called the Moore's Law, but in general, it's sometimes you might want to write an expression as a keep statement, sometimes you might want to write it as a drop statement, but it depends on what looks easiest for you, what you can read most easily. But we ask you to keep all observations that state an individual has a stated income. And so we can either keep the data set, and as you can see, one of the nice things I really like about Stata is when I delete data, it lets me know exactly how many observations I've removed. And I can also rewrite this the exact same way as instead of keeping everything that's not gross household income is unknown to dropping all cases where household income is unknown. And just to show you that real quick, the other thing I want to highlight is that Stata's do files will stop anytime it gets an unexpected error or syntax issue. So one of the things you'll often see folks do is type in a question mark or a random character that is known to sort of stop Stata in its tracks. And all I'm doing right now is we want to make sure that our keep and drop statements are both removing 164 observations. So let's run that from the top. And what we find is exactly what we expect. But if we keep all cases that are not equal to a gross household income is equal to category 4, versus if we drop all cases where household income is equal to category 4, we get the exact same results. So I'm just going to delete that. Now, the other question that we had some questions about was the relationship between gross household income and college education. And this is one of those things that often I'll have your cheat sheet laminates for you, but looking at the help command is really useful to understand how flexible some of these data commands are. So when I go to help tab, I see a couple of different tables I want. One way is for when I'm just doing calculations by one variable. Two ways for when I'm doing two or more. And so what I then do is I tend to look at the syntax, think about how best can I communicate the point I'm trying to connect. So let's just look at what tab profile gross household R is and college. If I just did it without any options, all I see are the raw counts. Just vaguely looking at it appears that there are a lot more instances where individuals make 80K if they went to college versus not. I can also do the same calculation with 40 versus 80K, but it's a little bit more confusing here. But generally, if I wanted to say communicate this more easily, what I might do is I might express this in percentages. And that's one of those things that's really nice about Stata as a command, that all of these things can be modified with options. And the ones that I think are nice here are these things called a column option, which let's take a look at what that's doing. And the other thing that's nice about Stata that I didn't mention is that it's got this thing called a history bar. So anytime you need to like access a prior command, you can just do that. There's also if you hit the page up button, you can just rerun or pull the code from the last command. So this percentaging by column, we can clearly see how individuals vary after adjusting for the total sample size. This is a little bit hard for me to read because I can't tell if I'm looking at a raw count or a percentage. So what I'm going to do is I'm going to look at this. There should be a frequency option. And what I see here is that no frequency is how I suppress counts. So I'm going to run that with this option, no freq. And now I can see the exact percentages very clearly. And what I can see is that individuals who went to college tend to make more money across the three different categories. And the other thing that I wanted to highlight is that if I wanted to break this down by rows, I could do that as well. And we see a slightly different distribution. And depending on the situation, whether or not you want to sum by rows or by columns or even by cells is going to depend on things. But I do want to highlight that all of this is really quite flexible. So figuring out what table makes the most sense for you is quite nice. Dropping. This is one of those elements of variable selection that, again, Stata is quite nice at. So we tried a few different things in class, and I want to go over some distinct approaches of how you can set up and remove certain sets of variables all at once. You do not typically need to type anything. One of the things that's really nice about Stata is that it will infer you ran the right command so long as it was the only one that makes sense if you give it an abbreviated form. So one of the things I end up typing a lot is this command display. So let's use hello world as an example. And all that does is print things out. I could write this and it will still work. I can even go all the way down to DI, hello world. But if I type the command D, hello world, what happens? It doesn't necessarily know what the command is because we know we have a couple of variables of commands that might be relevant. We have display, we have drop, and we probably have a whole bunch of others that we haven't really talked about yet. So we are going to do all that. The other thing that I want to highlight is that you can use wildcards. That's what this little star character is. So basically say, use any character that matches up until this point, and assume that this could be any character afterwards as well. The nice thing about this is you don't have to type a lot. The one thing to watch out for is that more often than not, you might accidentally drop something that you care about. So use this consciously. And also just try and rename your variables well so that when you can use these types of commands, but you aren't necessarily getting rid of of more than you mean to. The alternative, and in some ways I like this a lot more, is you can just specify a range of variables. And so that's what this fight rat minus fight goose is doing, is it's basically saying, go from here to here. And in fact, that is effectively the same set of variables, but this operator, the minus sign, basically says just look in the range of variables in this space. And you want to be careful about this because, so for instance, if I were to reorder the fight rat variables to the very beginning, and move it to the top of the list, and then I run the same command, what happens? And I would lose way more data than I intended to. I lost my college variable. I did not lose my college variable, but I lost far more than I intended. So let's rerun our data again. Again, let's use this question mark notation just so it'll run quickly. We get this question mark is not a valid command, and it stops right where we left off. And we see that our fights data is gone, and all of the other variables that we did want to keep, like age, gender, and whatnot, stayed. Great. So now all we're doing is checking to make sure how many observations we have left. We run the command. We see 35 variables and 1060. That looks good. I think I might have accidentally deleted one. I did not mean to. Let's just change that answer key right now. And finally, we've got some plotting questions. There are two things that I want to talk about with regards to plotting. One is that labeling axes is and titling your plots is very helpful, because as soon as you start to really feel comfortable with things, you are going to have lots more plots than you'll be able to keep track of in your head. So particularly if you use default plotting things, it's worth remembering what each thing is called. So if we just run histogram of sum scores, we see that instead of plotting the underlying sum score, it plots the associated label on the x-axis. And we can also tell it we want to plot a specific title. So this is my sum score. And yeah, you don't need to create particularly fancy titles for exploratory plots. But again, I think it's really helpful just to keep track and do sense making. And finally, saving graphs. There are a number of different file types you can save graphs as. I'm not going to go over all of them, but I tend to prefer JPEGs because they're a flexible file format. You can insert them into presentations. You can also save as a PDF or .graph file. The one downside that I'd sort of caution about saving things as a .graph file is that those are plottable objects in Stata, which means you can open up a graph file and potentially make some additional edits, which if you're tweaking a presentation, it might be nice. But generally, that means that you need to have Stata to read your plots and files. So I wouldn't recommend it, particularly if you have co-authors who don't have access to the software. So our next set of questions, who wins in a fight? There are a couple of different ways to do this. We'll get into how to do it programmatically using return lists and things like that next week. But for now, all I meant was for you to calculate the means between the two groups, read the total, calculate the means, read the total bottom line. Notice where the lowest values were, where the highest values were. One thing that is kind of unfortunate about Stata is it does not like really long variable names. So one thing you can also do to help that a little is you can sometimes transpose your data. So this time it was computing the means for each variable, but you can also do the exact same command and let it know to transpose things so it can be read a little bit more easily. So I didn't need, so I needed the option columns and variables. Again, a lot of different ways to display data. I think that's one of those takeaways that is going to be a theme throughout the remainder of class, is that there are a bunch of different ways to generate the same table, but depending on what your question of interest is, how you format things can make things very hard. So now, in a case like this, I didn't actually need gender for this specific question. I do need my wildcard character though. This might be a little bit easier. Intuitively, we can sort of know based on the ordering of these variables that winning a fight with a rat is the easiest. Winning a fight with a grizzly bear is the most difficult. We can use that tab stat by gender option for our next question, which is for which animals is the gap between men and women largest? So there are a couple of things we could do. We could use this tab stat command. That's one approach. We could use a by sort command or a for loop. So that's what I'm going to do here. And what this expression is saying, for every variable, of the variable list, that's all the variables here, that matches this expression, wins fights, wildcard. Go through, compute the mean of the win fights parameter, and then list it out. List out the first row of our data set for these variables when we're done. So that's what we're going to do. And that's another way we can see that. The one challenge is we created a lot of data that is just going to be the exact same feature, which particularly when you're working with really big data sets, this sort of calculation can be really wasteful and actually meaningfully affect your computation time. So how do we compute differences by gender? So there are a couple of different ways we can approach this. But one thing I'm a big fan of is there's this command called preserve. So anytime you're going to be doing a data step where you just need to get rid of some data temporarily, it's nice to know this option exists. What preserve does is let the Stata software know I might want to sort of erase some of the steps I've done. So how can I go back to where I was before I ran this command? Well, there's this command called collapse, which what it does is compute summary statistics and reduces our data set. So let's look at how many observations we have now. We've got 2 observations, 16 variables. And what's nice about it is we have our summary statistics and we have our data and nothing else. So that's really nice and efficient, but it's also hard to understand how we can go back. So what we want to do, we preserve, we collapse, and so one thing that is a little bit tricky is that running a preserve command in a do file will always restore itself after the do file successfully runs to completion. So this can make debugging really painful. So we see that we have only 2 observations. We type our restore command and our underlying full data set is back. That is all you need to take away for right now. What we can do is go through and we're trying to compute the difference. So the nice thing is now that we've got 2 columns, or 2 rows rather, we can just go through the male and female data set and compute the difference between rows. And this is again one of those other nice little features about this data. If we want to access where a specific row is living, there are these local variables that are kind of like the ones in your data set, but they are always there. They are, one is called _n, and what that'll do is return the corresponding row of an observation. And there's another one which is _N, and that will always return how many observations are currently in the data set. Which you want is going to depend on use cases. But one of the things that comes in handy is being able to just figure out what row an observation is in. And so this is one way of generating that. this n_n, which is basically saying for each row, return the number and index of the row. And let's just take a quick look at what that looks like. So 1 and 2, just as we expect. And once we have these sorts of orderings, we have ways of doing time series analysis, basically understanding which data follows which observation. And we can then start to do what's called time series observations, which is we can take the difference between periods. We'll talk a little bit more about this, I think, in week 3. But again, I just want to show you there are a bunch of different ways of doing this analysis. And you see we have the mean difference of across groups. And we can just sort of visually inspect where is this gap largest. And it seems to be that wins a fight with a medium-sized dog has the largest gap between men and women. And finally, the last step of our analysis is we're just going to generate some bar plots. Sorry, need to run this from scratch. And let's take a look at what this bar mean looks like. This I find really hard to read. So I will send some articles about how to create visualizations, but generally, if you have to do a lot of comparison across different points, reference points on different axes, it's very hard to see very clearly answers to questions of, is Northeast taller than South? Is Midwest taller than West? You can kind of compare across these two, but seeing all 4 is really tricky. So that's one of the things that I want to highlight. But instead, if we were to plot using this over option, I'm sorry, if we were to plot this over option, comparison becomes much easier. So again, just look at your help options quite often, and there are ways to make your visualizations easier and more accessible. And our last step is this 2-way scatter plot exercise. And one of the things that I think is worth spending some time understanding is that we only have 1,000 observations here. That might sound like a lot or a little, depending on your context. But what's really tricky is that it's not at all clear to me what the relationship between age and sun score is right now. And in part, that's due to a couple of reasons. One of which is I don't actually know how many points are on this plot just by looking at it. And there are a couple of ways we can help that. One is something called jittering. So let's take a look at that. So jitter options, you can basically perturb the location of points. What that is doing is just adding random noise, not a whole lot, but enough so that I did not need the graph command. Okay. So where was I going wrong on this? Well, I did not set a size for how much I should jitter. So I moved about 0.01. That wasn't a whole lot. Let's see if I did 0.5. We start to see a little bit more noise. It's still really hard to tell. So I'm going to show you a really nice package that I use quite often called bin scatter. What this does is it generates sort of moving averages of points across times and percentiles and plots a handful of them. So sometimes these approaches can be much more representative and readily lend sort of ready interpretation of data. So what we do is we run the command bin scatter x sum score age, so we can sort of model the relationship between sum score and age. And now we can see that there's a pretty clear downward trend that as individuals get older, they think they can eat fewer animals. And the last bit we're going to do on this exercise is we're going to save our final data set. And what we're doing is we use this option comma replace to overwrite any pre-existing files. I've done with graph a few times. And it's just good practice because this is getting behind that idea of idempotency, that we want our code to run no matter how many times it's been run before. So using this replace option is a nice way to ensure that. With that, I'll be posting a video later this week with more homework and an in-class assignment, but the slides should be posted and I'll get an in-class a pre-class activity up before weekends end. Thank you both so much.